If your organization is using Cisco Catalyst Center, you should be making use of its APIs to roll out config changes at scale. In this video, I'll show you a Python CLI tool that does exactly that. My name is Prajwal. I'm a senior network professional and welcome to my YouTube channel, Praj Automates. When we talk about config changes at scale, we would have come across tools like Ansible, Nornir, Netmiko. They are great, and if you are in a multi-vendor environment without a controller, use them. But if Catalyst Center is already running in your org, it has your device inventory, your templates, and a full REST API. Why not just use it directly? That's what Catalyst Template Deployer does. It talks directly to the Catalyst Center APIs using the official DNAC Center SDK. That's the Python SDK. The README file of this project is detailed. I have explained all the features, the requirements. We just need to install the DNAC Center SDK, how to configure this, and the usage. For the purpose of this demo, I have reserved a Catalyst Center instance in the DNS and Cisco DevNet sandbox. And if you look at the Catalyst Center, in the inventory, we have 4 switches here. What we'll do is we will shut down 2 interfaces on all 4 switches using a single command. So that's like a rolling configuration at scale. To check the current status of the interfaces, let's make use of the command runner tool. Let's select all the devices. I am selecting all 4 switches and I'm entering the command show interface description, shorthand command. So this is parallelly running on all 4 devices. And if I look at switch 4, all the interfaces are up. Switch 3, it's the same. Switch 1 and switch 2. We see all the interfaces are up. And if you are making changes through Catalyst Center, it has to always go through the templates. I have written the template to shut multiple interfaces. Let me show you the template and its logic. If you see the template hub, we have 4 templates here, and let me go to this one. In this, to briefly explain, we have 3 variables: the interface list, which accepts device interfaces separated by comma, and then you have the shutdown reason, which goes to the interface description, and then you have the backout. It's always a very good strategy to have the backout plan within the template itself. So if you want to roll back the change, you can just provision the same template saying I want to backout by setting the backout flag to true. In this case, if I don't give the backout value, it's by default going to the else part, and here we are using the split to separate the interface string, and we are using a for loop, and we will be like suppose we have 3 interface name given separated by the comma. This loop runs 3 times and it generates the config to shut down the interface. And suppose we want to roll back the change, we set the backout to true. So we set the backout variable value to true, then it is going to no shut the interface, and also it will do no description. Let's simulate this. We will see here. I had created the test simulation, and these are the 3 interfaces which I have given. I will set the backout to false for now, and this is a reason I will give. So if we run that, for these 3 interfaces, it is generating this config which will be pushed to the device. It is shutting down the interface. Now, if I want to roll this back, I'll give the backout as true. And you can see it is doing no shut on all 3 interfaces. Let me quickly demo this. I have installed the Catalyst template deployer here in my VS Code. We can see all the files here. For in order to initially set up, you need to give your DNS Center, like Catalyst Center credentials in the config.py. It will make use of this. And if you want to list what are the templates which are there, let's run Python 3 main.py. Main.py, this is a pretty detailed Python script which I have written. All these description of every function is written in the comments. You can read it and you can go through this and you will be able to understand that. Let me run Python 3 main.py. This is going to list what are the templates which are available in your DNAC. As we saw, we have 4 templates here. And if you observe, there are like 2 projects, network templates prod and network template stage. There is a reasoning behind it. We are making use of GitOps methodology to uh, and rolling out changes in the production. I will have a video about this soon. Now, if you do Python 3 main.py and give the helper, you can see what are the arguments it is taking. Now, if I want to inspect a template, I'll give -hyphen template and give the template. Let me do that. Python 3 main.py -hyphen template. Let me give the template which we saw. This is the template which we just went through. We can see the contents of this template, and here is it. So it is also giving what should be the example CSV header. So in this tool, we'll be giving CSV file as the input, listing all the devices and all these interfaces. So it will take hostname, interface list, and shutdown reason and backout. I've already prepared this interface list uh, like CSV file. The order of this doesn't matter, but yeah, we should have all the variables filled in. Now, I want to shut down interfaces on all 4 switches, and these are the random 2 interfaces that are picked. I'll set the backout to false for now. Let me run this. So I'll give this template and I'll give the input. I'll specify the input and input file path interface list. Let's run this. So if you see here, it has queued all switch 1, switch 2, switch 3, switch 4. It has taken all the parameters here and it is starting the deployment, and it has created the job ID and the deployment ID, and it says success. So it has successfully provisioned this template on all 4 switches. Let's look at them. Let me run the command runner tool again. I'm selecting all the same switches. Show interface description. So you can see here 2 interfaces are down with the description as test demo. Similarly, so on all 4 switches, our change, what we intended, has been successfully carried. Now I want to roll back the change on one of the switch. Say on switch 4, I want to roll back the change. Let me set the backout to true for this one alone. TRU. Now let's run this template again. So what happens here is, since the parameters of switch 1, switch 2, switch 3 didn't change, the templates for these won't get deployed, and only for switch 4 it gets deployed. You can see that here. So it says for these 3 switches, it's already deployed, and for only switch 4, it got provisioned again with the backout false. Let's see, let's go back and run the commands again. You can see for switch 4, it has rolled back, all the interfaces are up. I mean the physical interfaces. For others, it's still down because the template didn't get deployed. If you want to deploy it forcefully, even though it is deployed, because DNS Center maintains the context. If the template is already deployed with certain parameters, and if the parameters hasn't changed, it is not going to deploy that. So that's why I have also added the functionality of forcefully deploying it in case if you want. So if I do force flag, I've not changed anything. So ideally all 4 was not supposed to be changed. Now you can see it's trying again, and yeah. So it is provisioning the template on all 4 interfaces. Oh, sorry, all 4 switches now. even though it was already deployed. That is because we used the force flag. So that's for the demo. Let's get back to the whiteboard as to figure out why this is important, right? Why this SDK approach is much important. So you have your like automation tools like Ansible, Nornir, Netmiko. If you are using the SDK approach using Catalyst Center, there is no need to SSH the devices. The SDK makes the HTTPS call to the Catalyst Center. It handles the device connectivity. There is no extra firewalls needed per device, or I mean firewall rules, and there is no requirement of stored device credentials. And main thing is no duplicate inventory. Your devices are already in Catalyst Center. No separate host file is required in case of Ansible. This eliminates another second source of truth. So CatC already has the creds. You need not maintain it separately for every device. And another thing is built-in deployment tracking. Every deployment gets an ID, then a per device status on whether it's a pass or a fail, then the timestamps, and you get everything from the API. There is no need for a custom logging to set up for this. Next is the template governance, right? The template lives in the template hub, their version. They have the drift detection and compliance visibility just out of the box. You're not replacing Ansible, but you are eliminating the need of it when the controller already does the job. So if I have to give you the code overview, let me adjust this. So the input, as we saw, is a CSV file. We saw that it was just like a spreadsheet, and it has the hostname column where you specify all the devices and whatever the parameters your template needs. The first thing the script does is call batch run batch from the CSV. It opens the file, strips all the extra white spaces, make sure the hostname column is actually there. While it's doing that, it also calls build a device map. This hits the Catalyst Center inventory API and builds a lookup table of every device, hostname on one side and the internal UID on the other. For large networks, this is paginated. So it uses fetch device page. It is running concurrently across multiple threads to pull it all faster. Then resolve template ID takes the template name you passed on the command line, finds it in the catalog and grabs the UID of the latest committed version. Now we have everything we need. Now, submit and Paul assembles one bulk payload with all your target devices and fires it at the Catalyst Center using the deploy API in a single call. Because that API is asynchronous, the script then loops, uh, polling the deployment status every 10 seconds. We saw that until the job reports a finish time or hits the 30-minute timeout. That's what I have written in the code. Finally, the deployment summary prints a clean device table, the IP address, status, and any detail message. So you exactly know what happened on each device. And initially, when we were trying to list the template, when we call the main.py, this list available templates function is called, and also inspect element, in inspect template, when we give -f and template and the template name, this function is called. So this is the overall code overview, and the the code and the README are linked in the video description. Um, Clone it from the GitHub, point it to your controller, and see how fast your deployments can get. Thanks for watching. I hope this was informative and helpful. See you in the next one. Cheers. Bye bye.